5 Important Discoveries by Heinrich Rudolf Hertz. Heinrich Hertz, 1857 to 1894, was a renowned German experimental physicist whose discoveries over a period of 10 years served as the foundation stones of modern communication technology and quantum mechanics. Hertz was homeschooled from age 15, as he was an outstanding student who showed proficiency not only in the sciences, but also in foreign languages, such as Arabic and Sanskrit. In 1930, the SI unit of frequency was named Hertz in his honor. 1. Inertia of electricity. Hertz studied under physicist Hermann von Helmholtz at the University of Berlin. In 1878, Helmholtz was involved in a fierce debate with a colleague. Does electric current have mass? He announced a prize to anyone who could answer the question. At that time, electron was not yet discovered, so it was a big ask. Hertz accepted the challenge as it gave him immense pleasure in learning directly from nature through well-thought-out experiments. After 1 year of hard work, Hertz settled the debate by showing in a series of experiments that if electric current had any mass at all, it must be negligibly small. Nearly 20 years later, electron was discovered by J.J. Thomson. 2. Radio waves. Hertz was 7 years old when James Clerk Maxwell wrote the famous equations of electromagnetic theory. No one was able to generate electromagnetic waves until Hertz in 1887. Hertz was 30 years old at the time. Hertz was demonstrating electrical sparks to his students in 1886. He noticed during the lecture that sparks produced a regular electrical vibration within the electric wires. Hertz thought that this vibration was caused by accelerating and decelerating electrical charges. If Maxwell was right, this would radiate electromagnetic waves through air. When Hertz was asked in an interview the use of electromagnetic waves, he replied, "Nothing, I guess. This is just a homemade experiment that proves Maestro Maxwell right." 3. Electromagnetic spectrum. Hertz calculated the speed of radio waves he created and found it to be the same as the speed of light. This was an experimental triumph, as he had proved yet another prediction of Maxwell. He also showed that the waves radiating from his oscillator could be reflected, refracted, polarized, and produced interference patterns like light. In 1990s, Hertz also worked with ultraviolet and X-ray. He concluded that ultraviolet, radio, X-ray, and light are part of a large family of waves which is today called the electromagnetic spectrum. 4. Photoelectric effect. In 1887, Hertz observed that an electrically charged metal, when put under ultraviolet light, lost its charge faster than otherwise. This is called photoelectric effect. As Hertz was an experimental physicist, he did not try explaining the phenomenon. Theoretical physicist Albert Einstein was a young boy in Munich at this time. In 1905, Einstein wrote the theory of photoelectric effect and won the Nobel Prize for the same in 1921. This work played a key role in the development of quantum mechanics. 5. Contact mechanics. Hertz wrote a paper in 1881 outlining the field of contact mechanics. Contact mechanics is a part of mechanical engineering in which engineers study the touch points of solids. The principles of contact mechanics are useful in applications such as rail-wheel contact, braking systems, and tires. Summing up, Heinrich Hertz was only 36 years old when he died of complications in surgery to fix his constant migraines. In just 15 years of his scientific career, Hertz made pioneering contributions to various fields of physics. From Maxwell to Einstein, Hertz is the famous experimenter whose observations either confirmed a previous theory or laid groundwork for a new theory. Hertz is among the few scientists in whose honor an SI unit is named.